a string of numbers, right? But we can break it down. So the first number is going to be the tick. That's the turn. That's the where we are in the game, right? That's always going to be integer. These chars right here are always going to remain the same. These never change, and they basically describe what is to the right of them, right? So F describes the floor number. Floor number is obviously going to change, right? That is the floor number that the person can spawn on. T is going to be the target floor. That is where they want to go. That's also going to change, right? And then we have A, which is their anger level. That's also going to change. And when you begin to start testing your person class and you actually start testing, I suggest that you go into these game in files because there's going to be a whole bunch of people to spawn, and you can just copy your person data. That's funny. Am I hilarious? Thank you. Yeah, so I suggest, instead of like, if you really do want to create a person from scratch, you can obviously follow me this right here. But if you don't, you can just go into those game classes and straight up copy a person, right? Using this breakdown. And also, now that you've seen that this breakdown happens, I hope that you will know how to create a person when it comes down to implementing that person constructor, right? So that's person, and then tick increases the person anger level as the game progresses. You know, you have that lovely anger level right there, and it's going to increase every time you don't pick them up, which is understandable because, you know, I don't know if you've ever been in that elevator in Mason Hall, but oh my God, right? That is the worst elevator you can call me. Anyway, so using these right here, you're going to break down the string and construct a person from it, right? That's why it takes in that input string. And so hopefully looking at this, you have an idea, like you're probably going to read in from the string and, you know, take each thing. You can just throw away these lovely chars because they do not matter. String. That's how you're going to do it, right? String is essentially what you guys have been doing with these CN strings and these N strings this entire semester. It supports the extraction and insertion operator, right? Cout, CN, those both take extraction and insertion operators, like so. And we want to do both, so that's why we have string. If, you know, you have a list, that's okay. You don't have to say it. You can just say like string input thing or whatever. Anyway, so we declare string S, right? Same thing that you do with N strings, O strings, in files, etc. And we have this lovely string nums that we want to break down and put into variables. And so we're going to read nums into our string, right? And then we declare int next num, and it's just, we're going to take it and put in the next num, right? And it's going to read up to that first white line, white space. So we got 1, 2, 3 right there, white space, boom. Next num is equal to 1, 2, 3. And we do that 1, 2, we do it 3 times. So I was say we do it 3 more times, but we don't. Right? Don't make it more complicated than it needs to be. Right? You've seen strings and see it. So if you are still a little bit confused, I want you to look at some of those past projects you've been working on and the way you've taken an input into strings, especially how the string works. Right? And then elevators, right? Every person has to get on the elevator. So elevator class, you have primary variable servicing, current floor, target floor. Servicing is the status of that elevator, whether or not servicing. True if it is servicing, false if it's not servicing. And we're going to want to change that if current floor is not equal to target floor, right? So obviously I'm not where I need to be and I need to get there, so 9 times out of 10, this elevator is going to be moving. Current floor, right, where it is, target floor, where that's it. And then we have these public member variables. Tick, right? We've seen that before, that's just going to move time forward, it takes in the current time. And void service request, that is how you're going to make this request, that is how you're going to edit these lovely little 2 variables right here. 1 variable. It's going to allow the elevator to move as the game time passes, and it's going to set the elevator to not servicing once it's reached that target floor, right? So simply what it sounds, when the current floor is equal to the target floor, you're going to change that servicing variable. And then service requests, you see that that parameter is floor number. That is where you want to take that elevator to. So think about what that is going to change in here, right? It's going to set a new target floor, and it's going to also set servicing to true. All And then also recall how to make those elevator service moves, like we went over a bit earlier today, 5 minutes ago. Hopefully not like me inside the door after we've been so quickly. But yeah, do we have any questions about any of the two things that I just went over, or three? There's a lot. Any questions on elevator or person? Cool. Amazing. Okay, I'm gonna pass it off.
Okay, now we're going to talk about floor. So how I like to think of floor is, let's say you're waiting for an elevator and there are a bunch of people around you. Some of them are really mad that the elevator isn't coming. Some people are just like chilling there, like it'll come when it'll come. But floor is basically just an array of people who are waiting for an elevator. So here are some of our public and private members that our floor class has. So the main thing that you want to pay attention to is that array of people. So these are all the people that we talked about before that are waiting for the elevator. And then we're going to have the number of people that are going to be in this array, the number of people that are waiting, and then our has up request and has down request variables are going to tell us whether or not there is someone with an up request or there is someone with a down request. And both of these could be true, or both of these could be false, or a combination of the two. So if there's even one person on the floor with an up request, that up request variable is going to be true. And then reset request just is a function that's just going to go through and make sure that our up request and down request are accurate based on whoever's on our floor at the current time. And then, as we talked about tick before, tick just moves things forward in our game. So the main thing that our floor tick function is going to do is it's going to go through each person in our array, and it's going to tick all of those individual people. So it's going to update whatever data we have about them. And all we have to do is call the person's tick function. And then we have add person, which is going to add someone to that floor. And then we have remove people. And then our remove people function is going to it's going to take our indices to remove array, which is just going to tell us the indexes of the people that we want to remove from the floor, and it's going to do that action. It's going to take people out of that floor. And that's going to be that's one of the more challenging functions of this project. Okay, so here we have an example of a people array and floor. So remember that arrays are going to be fixed in size. So the arrays can't change in size, but that doesn't mean that we always have to care about every single person on the floor. And there are special ways that we can write our code so that we don't have to care about every single person on the floor. We only care about the specific people that we're looking at. Okay, so let's say we generate a floor. At first, because of our default constructors that we learned about when we were coding our last project, there's not going to be any people on the floor. So this getter, this getNumPeople, is going to return 0, because initially when we create a floor, there's not going to be anyone on it. There's no one waiting for the elevator. If we add a person, then we're going to add a person to index 0 of our people array. So now, if we try to get the number of people, that should return 1, because we just added someone to the floor. And we could do this a bunch of times. You'll see in the next example, we add another person, and now getNumPeople is going to return 2. So each time we add someone, it's going to update the number of people, and it's going to update a couple of other things too, as we talked about in the other functions. As I mentioned before, the remove people function is probably one of the hardest to code in the core. There's a really awesome video. When I was taking this class, I probably watched that video maybe 4 times, just because I watched it when I was trying to figure it out, and then I watched it as I went, and I paused it a bunch of times. So make sure you give yourself time to do this function. There are a lot of little things that you might not think about, but the video is super helpful in helping you figure those little details out. So I definitely recommend watching the video. Okay, now, does anyone have any questions about floor? Okay, you can feel free to ask them later as well. Now we're going to talk about move. So far we've talked about a lot of physical things that are pretty easy to imagine. We have a person, which is a part of a floor, and then we have an elevator. But without move, all of those are just going to stay sedentary. None of them are going to change. Move allows us to take input from the user, what we call the command string, and then do something with that input. It allows us to take that string and then take some action, make a move in our game. So here we have the types of moves. Hayu talked about these earlier, so we'll go through these fairly quickly. We have a pass move, and usually you can just do a pass move by hitting enter. That's when all of the elevators are busy, so we're just going to keep continuing because there's nothing we can do. A service move is when we want to send a certain elevator, in this case elevator 2, to a certain floor, in this case floor 5. So that's when we're sending an elevator somewhere. A pickup move is when we're on the floor that we were trying to get with this elevator. So now, what do when the elevator gets there? You want to pick up the people on that elevator. Because if you kept moving, then the people would never be picked up and there was no point of sending the elevator there anyways. So a pickup move picks up the people on that floor when you're where you wanted to get. And then remember that in real life, when an elevator is moving, it can't pick up people on a certain floor if the elevator is moving. That's not possible. The doors wouldn't even open. So an elevator must be at rest in order to pick up the people on that floor. It has to have reached its target floor. And then S is to save the game, which you can load later. And then Q is if you want to quit the game, you say, I'm done, I don't want to play it anymore. So here we have some of the public and private members of Move. So the Move class just stores everything we need to know to make a move during our game. So of note, we have our elevator ID, our target floor, an array of the people that we want to pick up, number of people to pick up, total satisfaction, which again is just a metric of measuring how happy people are in the game and how well you're doing as someone playing the game, and then what type of move it is. And we have bools that help us indicate that. And then for our public members, we have our constructor, which, as we talked about, takes in a command string, which is just one of these strings that we just talked about before. And then we have set people to pick up, which essentially takes all the information from our pickup list and then converts it to our people to pick up array. And then it does a couple of other things too, and modifies some of our private numbers. You'll see all of this in the RME. And then we have whether or not it's a valid move. And as Hayu talked about, if it's not a valid move, it's not going to let you do anything. And that's the way that we check if it's a valid move or not, is by implementing this function. Build it. Oh, does anyone have any questions about move? Okay, let us know.
Alright, so now about building. For the building class, we just have 3 functions to implement. So in the building class, we can see we have several private member variables that are of, for example, we have an elevator array, we also have a floor array, so really being careful that we call the right class as member functions on a certain variable. And I would definitely encourage looking at the spec. If you go to the page specifically for building, as mentioned before, there's a function table, and it also includes the classes of different functions you might want to call. So for example, in the spawn person function, it says that you want to call get current floor, and that is in the person class, and also you want to call add person, which is in the floor class. So the spec is definitely a helpful resource. So update is one of our functions, which we will call whenever a user enters a game command, and the update function essentially updates certain private member variables of the building class. Then we have tick, which orchestrates 1 unit of time in the game. And I know previously we also mentioned the tick functions in the elevator as well as floor classes. So in the buildings tick function, we essentially want to call the tick functions of the elevator as well as floor class. And then for the spawn person class, we are simply adding a person to the game. And you can again check the function table for for what that requires of us when it comes to coding. And there's just a note, check out how the building contains all floors and all elevators. We can index into or loop through these floor or elevator arrays to access each floor or elevator, and also use their public member functions or variables. So that is building. And then moving on, we also have the game class, and we can sort of take a quick look at the variables and functions involved. So we have a building variable, which will contain, again, the elevators and the floors that we will be working with in one instance of the game. And then we also have a satisfaction index, as well as the mode, is it the AI mode or is it not? And now we have the functions. So the play game function of the game class, we are going to write that, and essentially puts the game together. So the play game function is called at the very end of main.cpp, and the play game function repeatedly calls certain other functions. So for example, get, move, or update, and since it says repeatedly calls, that's an indication to us that we might want to be working with a loop here. And specifically, we also want to work with input files in the game. So we want to work with a loop as well as with input from file. After play game, we also have a function called isValidPickUpList, which is called whenever a user enters a pickup list. And we essentially want to do a lot of checks in this function as well. So similar to other functions such as isValidMove, we essentially want certain if statements. We want to ensure that the entry is well formed. So as in we want to check for no duplicates, no negative person indices. Everyone is going in the same direction. We want to check all these requirements essentially on a user entered pickup list, which will be a string. Does anyone have any questions on game? Now we can move on to the reach.
Now we're going to start talking about our reach, which is super exciting. So our core has human commands, which is stuff that if someone took your computer and wanted to play your game, that's how they're going to play their game. They can type in their own commands, they can make their own choices, and humans are looking at the screen instead of a computer. But reach is where we get more exciting. Reach is where you can actually write the AI for your computer to play the game for you. So what we're doing in reach is you're going to think of the best strategy that you can in order to win the game and make sure you have the best score that you can. And as you hit enter on your keyboard, the computer is going to be making those choices based on the code that you write. So our two functions that are going to be the main functions of our reach are going to be getAIMoveString. So that's going to be where you will make the choice on what type of move your AI is going to make, and that's based off of the move class that we talked about a little earlier. And then getAIPickUpList. So if it's a pickup move, then you're going to write a function that decides who the optimal people on the floor are to best pick up. And then AI functions are going to look at their arguments to make choices. So we'll look at our building state, which is how we'll make choices. So at first when I looked at this, when I was doing this project, I was like, oh no, what's a struct? I didn't learn about this yet. I was freaking out. And I went on office hours, and they said, you can treat a struct exactly like you can treat a class. And that's exactly what I'm going to tell you now. You can treat these structs exactly like how you can treat a class. You can make an instance or object of a struct, and you can use that to make choices in your reach. You don't exactly have to worry about your reach now because you're going to start doing your core first, and that deadline comes up first. But this is what you're going to use. So all of these different structs are going to be in your building state.h file, and you don't modify this file, and it's just going to store data that you can use. And then, yeah, so you treat it like a class, and then your turn is just going to be, I think of turn as synonymous with time. And then it just stores all the information that you can use in your AI. And then satisfaction index is going to be how you decide that you're doing well. So sum index is going to keep track of people's satisfaction. It's going to sum up how happy everyone make some choices. Maybe you want to make choices if the sum of up requests is greater than the sum down requests. Or anyway, you have so much creative freedom with the reach, so you can decide. And then sum exploded is how many people have exploded so far. You definitely want to keep this as low as you can. And then sum idle.
Cool, thank you, Emma. Okay. So that basically is an overview of both the core and the reach. That's all the stuff that you're going to be responsible for implementing and submitting to the audit grader, and that's what you'll be getting graded on, of course, besides the showcase, which is like a whole other thing. But now we're going to talk about testing for this project, so let's go ahead and take a look. So unlike the previous projects, you are not going to be graded on your test cases. So you will not be submitting those to the audit grader. You won't have to be like exposing bugs or anything like that. So then I guess the question is like, why should I test them? And like you've kind of been talking about that in lecture and in the lab throughout the semester. We should test because it helps us understand each function, right? If we are trying to implement a function and we don't know how it works in terms of what the input and the output is supposed to look like, how are we supposed to actually implement that function, right? So testing allows you to think about what inputs can I give the function, what outputs should I be expecting from them. You can write your tests first, so that way, when you implement your function and you're trying to see if it's correct, you run your tests and you build your own little mini like audit grader on your own computer, and that will just help you inspire confidence in you that what you've done is either correct, or it will allow you to use a debugger to like fix problems that you may have inside your functions. Yeah, and then one other thing is if you had made an elevator, would you have let a lot of people on it without testing every little detail of its functionality, right? What if there's a bug in there and like the cable snaps and it falls? Like, wouldn't be good. You should have tested your elevator. So testing for classes, we went over Project 4 and Lab 7. That's kind of like the central resource for where you can learn to test with classes because it's kind of different from like testing for the individual functions. So check out those two like assignments that you've completed for how to test on classes. How many tests should I create? Try and create one test suite for each class, right? Because again, the really big idea here is this is a very large and complex project with lots of moving parts. So you want to make sure that like the foundation for one part is very solid and secure before you move one level of abstraction higher. Because if you have problems with the foundation, then the whole building is going to crumble. So make sure you're doing that testing. And then one other thing too, we talked about setting up the working directory, which is very important for making sure that people can get spawned. If you think that you want to have very targeted testing, you can go ahead and create your own .in file to like decide when people are going to be spawning and where. This could be useful for testing your AI. Maybe you're failing a test on the audit grader that's called like morning. The idea with the morning test is there are a lot of people really high up in this apartment building who are trying to get to work. So the idea there is there are going to be lots of people spawning like on the floors trying to go down. Maybe you're not doing super well on that test because you didn't think about it in your AI. So you can create an input file where you spawn a bunch of people up at the top of the floors, and then you can improve your AI from there. So testing is for your own benefit. And then sometimes the only way to figure out if you're doing well on the AI part is to submit to the audit grader. Because that's really going to be like the oracle that tells you, yes, like it's performing well in all these different cases, or no, it's not. Yeah. And then just some teamwork tips. We mentioned this earlier, but for this project, you are required to work in a group of 4, including yourself. And so maybe for projects 3 and 4, you didn't work in a group, that's totally fine. I didn't work in groups for those projects either. And then the final project was actually canceled for me because of COVID. But for all of you, you're going to be required to work in a 4-person group. And that might be something that's very new to you, like even in college too, like if you haven't worked on a group project, these can be kind of difficult to do with the group, and group dynamics can be oftentimes trickier than the project themselves. I definitely have had some very bad group experiences, so these are just kind of a bunch of tips that we wanted to compile, just to like give you guys a head start in terms of what does a really good team dynamic look like. So first of all, we strongly recommend that you program together in person when you can. Because research shows that pair programming, which is kind of like the term for like everybody's in person, staying together, working on one laptop, that's called pair programming. It takes 15% longer, sure, but The benefits of doing that is it significantly improves your design quality and reduces the number and severity of the bugs that you have, right? So a little bit of extra investment at the beginning can save you lots of headaches in the end. So we totally recommend that you pair program. It's also more enjoyable according to the study that was done. Yeah, the other thing too about like working together is that it's hard when groups come to office hours and they're like, our code is broken, my partners wrote it, and I don't really know how it works. Can you help us? And with the earlier projects, that was kind of easier to do, but now that we have all these different layers of complexity, it's not so easy for the TAs just to sit down and open your code and look around at what's going on. So we really need guidance from you guys. So if you guys know what's going on in your code, we can help you faster. Yeah, starting early together, I know we've been harping on you guys like, start your projects early, please. But this project is definitely very long and complex, so starting it early is going to give you the time that you need in order to successfully complete it. Starting early together doesn't have to be coding. I recommend that you all get together just one day, sit down, open the spec, read it together, and just talk about all the things that maybe you don't understand. You don't have to know every nitty-gritty little detail, but you should have kind of a good understanding. Hopefully after this review session, you also have a good understanding of what the spec is asking of you. Other thing too is to meet up consistently throughout the project. So maybe 2 or 3 times a week for a couple hours or a few hours at a time. You all meet up at the union or something like that, sit down, work on the project. I promise it's going to save you lots of headaches in the future. And then to answer the question that was asked at the beginning of this session, how am I supposed to share my code if I'm working on Xcode or Visual Studio on a Mac, different computers and whatnot? How you recommended that we work in person together, which obviously kind of eliminates that, but I know that's unrealistic because we're all very busy people, have lots going on in our lives, so it's a good idea also to have a Google Drive, like folder, that you share with your group. You can create a Google Doc inside of there to write down all the questions you might have for office hours, jot down your ideas, things you're confused about, and also document your progress. And inside of that same folder, you can also just, whoever has been typing on their laptop the most up-to-date version of their code, they can just take all those CPP files and put them inside of that Google Drive folder for all the teammates to access. They can just go there, delete the old ones from their project, download the new CPP, get the new version of the CPP files you all have been working on, straight into your project, and then suddenly you have the most up-to-date version of the code. In later classes, you'll learn about like other ways to do it. We used to try and teach Git, which is a version control, but that has a lot of overhead and it can be kind of messy sometimes. So we really recommend that you guys try and do Google Drive. And if you use Git, we can't guarantee that we'd be able to help you, but we can do our best. So yeah, Google Drive is probably the way to go. So that is kind of all the material that we have for you today. We were wondering if you guys had any questions. Feel free to leave now if you don't have any questions, but at this point, you can answer questions, and then also you can feel free to walk around this room to find a team if you're looking for a team.
Let's just say that if you